After taking a long detour, we have finally come back to our original topics, electricity. But as I have already promised, now we will be able to understand things a bit easier and better. Almost everything we have discussed until now regarding gravity directly applies to electricity. In fact, mass is sometimes called gravitational charge because just as electric charge gives rise to electricity, mass or gravitational charge gives rise to gravity. There is an obvious dissimilarity though. Gravity is always attractive, but electric force can either be attractive or repulsive depending on the polarity. But that fact automatically gets taken care of when we consider charges can either have positive or negative value, unlike mass. Let's pull up a side-by-side comparison between gravity and electricity. Gravity is caused due to mass, usually denoted by m, and is measured in kilograms. Electric force, on the other hand, is caused by charge, usually denoted by Q and measured in coulombs. Both kilograms and coulombs are, of course, SI units. Next, in the case of gravity, we had gravitational potential energy, and in the case of electricity, we have electric potential energy. Both of them are denoted by U and measured in joules, SI unit for measuring work and energy. Then we have gravitational potential on the left versus electric potential on the right. Again, both of them are denoted by the same letter V. Gravitational potential doesn't have any specially given unit, but since we multiply mass with gravitational potential to get the energy, the SI unit will be joules per kg. Electric potential, on the other hand, does have a specially named unit. It's measured in volts. Most of the time, volt is shortened just by writing V. Electric potential is also called voltage, and in fact, this is why we denote potential with the letter V. And of course, we can use both of these energies to do work. Work is denoted by W and is measured in joules, just like energy. Even the formulas are same in both cases. For example, if this bowling ball was at a location where the gravitational potential V was 2 joules per kg, we would use the U equals mv formula to calculate the associated gravitational potential energy. Now, if the ball moved to another location that had a gravitational potential of -1 joules per kg, then it would have a gravitational potential energy of -2.5 joules. After the ball was moved, it should have 7.5 joules of energy less than it had before, and that would be the work. Because this 7.5 joules of energy can be used to do other things. By the way, we could use the same formula W equals m del V to calculate the work as well. Here, potential difference del V, that is gravitational potential at the starting point minus gravitational potential at the ending point, will be 3 joules per kg. And when we multiply the mass with the potential difference, we get the same 7.5 joules of work. In the case of electricity, we have this equation U equals QV for electric potential energy. That means if we took a positively charged object with 2.5 coulombs and put it at a location where the electric potential is 2 volts, it will have an electric potential energy of 5 joules, just like its gravity analog. If the charge moves to somewhere with -1 volts of electric potential, then it would have an electric potential energy of -2.5 joules. While the charge was moving, it would have done 7.5 joules of work. Because just like before, during this process, the charge has converted 7.5 joules of energy into some other types of energy. And again, if we wanted, we could use this analogous formula U equals Q del V. Here, the potential difference del V, that is electric potential of the starting point minus electric potential at the ending point, will be 3 volts. And when we multiply that by the charge, we get 7.5 joules of work, just like before. So you can see gravity and electricity are very similar indeed, down to the equations level. But of course, mass is always positive, whereas charge can either be positive or negative. Before moving on, I would like to review a few takeaways from all the previous lectures. First off, energy is an object's own property, just like mass, charge, velocity, etc. So energy is something that the object itself has. On the other hand, work, potential, or force are environmental influences on the object. They are the result of the object interacting with other objects or the environment. If there was nothing else in this universe without that object, then there would be no work, potential, or force. So, work is not something the object itself has, but the environment can make it do. That's why it is called work. Then there is that universal law we talked about. Object always wants to move from a location of higher potential energy to a location of lower potential energy. That means if there is a way to lower its potential energy, object will spontaneously lose that excess energy and convert it into some other types of energy. If instead you wanted an object to move from a lower potential energy to higher potential energy, then you would have to put some energy into the system and do it yourself. The object will not do it spontaneously. And then there was those formulas for calculating potential energy and work done using potentials. So far, we have seen how mass and positive charge nicely follows all these points. Negative charge should also do the same. Let's see if we can do all the calculations correctly for the negative charge as well. So, if the charge was negative 2.5 coulombs at the 2 volts location, it would have an electric potential energy of minus 5 joules. And at the negative 1 volts location, it would have 2.5 joules of electric potential energy. So the potential difference del V, that is electric potential at the starting point minus electric potential at the ending point, is 3 volts. Multiplying that by the charge negative 2.5 coulombs gives us the amount of work done. But there is an issue here. The charge is moving from lower potential energy to a location of higher potential energy, which is not spontaneous. That's why work here is negative. This negative value implies that we will not get any energy out of this process. Rather, we will have to put some energy into the system to make this happen. So the charge will spontaneously move from the lower position to the higher position instead. And when it does that, the potential difference del V, that is electric potential at the starting point minus electric potential at the ending point, will be negative 3 volts, which means the amount of work will be 7.5 joules, which is positive, meaning we can get some energy out of this process. So, to summarize the situation, for the same setup of electric potentials, negative charge will move in the opposite direction of positive charge. Both of them are spontaneously moving from a location of higher potential energy to a location of lower potential energy. So they are not violating the rules we were talking about. But in an effort to do that, positive charge has to move from higher potential region to lower potential region, whereas negative charge has to move from lower potential region to a higher potential region. So, always be wary of this fact, because we will definitely encounter this fact in the next lecture.